Picture a mission that seems impossible, sending a spacecraft to touch the surface of a rock the size of a building, hurtling through deep space at speeds exceeding 100,000 kilometers per hour. While this might sound like something straight out of science fiction, it's precisely what humanity has achieved. This remarkable feat represents one of the most daring ventures in the history of space exploration, pushing the boundaries of what we once thought possible. In 2022, NASA accomplished one of the most ambitious missions in the history of space exploration, when the OSIRIS-REx spacecraft successfully returned to Earth, carrying precious samples from asteroid Bennu. These seemingly modest pieces of rock and dust are far more valuable than their appearance might suggest. Within these cosmic specimens lie potential answers to some of humanity's most profound questions about our origins. They could hold secrets about the formation of our solar system and possibly even provide clues about the emergence of life on Earth itself. This extraordinary achievement didn't happen overnight. It required decades of scientific advancement, technological innovation, and unwavering determination from thousands of scientists, engineers, and researchers across the globe. The success of this mission represents not just a triumph of human ingenuity, but also opens new chapters in our understanding of the cosmos. As we continue to analyze these samples, we're not just studying space rocks, we're reading pages from the ancient history of our solar system, written in cosmic dust and preserved for billions of years. The story of these asteroid missions captivates our imagination and reminds us that the line between science fiction and reality continues to blur as we push the boundaries of human achievement. It stands as a testament to our species' insatiable curiosity and our relentless drive to explore the unknown, no matter how challenging the journey may be. 3 decades ago, the concept of visiting an asteroid seemed like an unattainable dream, relegated to the realm of science fiction. The immense technical challenges involved in reaching these small, rapidly moving celestial bodies made such missions appear nearly impossible. The sheer complexity of calculating trajectories, developing precise navigation systems, and creating spacecraft capable of operating millions of kilometers from Earth deterred even the most ambitious space agencies. However, the landscape of space exploration changed dramatically in 2001 when the Near-Shoemaker spacecraft accomplished what was previously thought impossible. This NASA mission made history by becoming the first spacecraft to land on an asteroid, touching down on 433 Eros on February 12, 2001. The landing itself was a feat of extraordinary precision, considering that Eros is an irregularly shaped asteroid measuring approximately 34 kilometers in length, tumbling through space at tremendous speeds. The success of Near-Shoemaker marked a pivotal moment in space exploration. As Dr. Sarah Connor from the European Southern Observatory explains, this mission opened the doors to a new era in space exploration. It proved that we could not only reach these ancient space rocks, but also study them up close. The technological advancements and scientific knowledge gained from this mission laid the groundwork for all future asteroid exploration endeavors. The mission's achievements went far beyond the landing itself. During its year-long orbit around Eros, Near-Shoemaker collected unprecedented data about the asteroid's composition, structure, and history. The spacecraft's suite of sophisticated instruments provided detailed images and measurements that revolutionized our understanding of these primitive solar system bodies. This historic mission demonstrated that with the right combination of technological innovation, scientific expertise, and human determination, we could overcome seemingly insurmountable challenges in space exploration. The success of Near-Shoemaker not only validated the feasibility of asteroid missions, but also paved the way for more ambitious projects like OSIRIS-REx and Hayabusa2. It marked the beginning of a new chapter in humanity's journey to understand our cosmic neighborhood. transforming what was once considered impossible into a launching pad for future discoveries. The mission's legacy continues to influence space exploration today, serving as a testament to human ingenuity and perseverance. It reminds us that what seems like an impossible dream today might become tomorrow's reality in the ever-evolving field of space exploration. The OSIRIS-REx mission stands as one of NASA's most ambitious and successful asteroid exploration endeavors. Launched on September 8, 2016 from Cape Canaveral Air Force Station, this groundbreaking mission embarked on an extraordinary journey to study and sample asteroid Bennu, a primitive celestial body that has remained largely unchanged since the formation of our solar system. The spacecraft's journey was nothing short of remarkable, covering an astounding distance of 2 billion kilometers through the vast emptiness of space before reaching its destination. This lengthy voyage required precise calculations and multiple trajectory adjustments to ensure the spacecraft would intercept Bennu's orbit. After 2 years of traveling through deep space, OSIRIS-REx finally reached its target in December 2018, making history as it began its detailed survey of the asteroid's surface. What followed was an intricate celestial ballet that pushed the boundaries of space engineering. The mission team choreographed a series of delicate maneuvers to gradually bring the spacecraft closer to Bennu's surface. This complex spatial choreography involved carefully planned orbital insertions and surveys, allowing OSIRIS-REx to map the asteroid's terrain in unprecedented detail. The spacecraft had to navigate around a body with minimal gravity while avoiding debris and accounting for solar radiation pressure, all while maintaining precise control over its position and orientation. The mission's most dramatic moment came on October 20, 2020, during what scientists affectionately termed the kiss. In an astonishing display of precision engineering, OSIRIS-REx descended to Bennu's surface and for just 6 precious seconds made contact with the asteroid. During this brief touchdown, the spacecraft's touch-and-go sample acquisition mechanism released a burst of nitrogen gas that stirred up surface material, which was then collected in the sampler head. This momentary contact, lasting no longer than a heartbeat, was the culmination of years of planning and represented humanity's first attempt to retrieve samples from an asteroid for return to Earth. The success of this touch-and-go maneuver was even more impressive, considering Bennu's challenging surface conditions. Unlike initial expectations of finding smooth, sandy areas, the asteroid's surface proved to be littered with boulders and rocky terrain, requiring the team to target a landing site roughly the size of a small parking lot. The precision required for this operation was equivalent to landing a spacecraft the size of a van in an area the size of a few basketball courts, all while the target was moving through space at tremendous speeds. In September 2023, after a 7-year space odyssey, OSIRIS-REx successfully delivered its precious cargo back to Earth, dropping off a capsule containing approximately 250 grams of pristine asteroid material. This sample, now being studied in laboratories across the globe, represents the largest collection of extraterrestrial material returned to Earth since the Apollo moon missions, promising to reveal new insights about the early solar system and possibly the origins of life on Earth. The OSIRIS-REx mission has not only demonstrated humanity's incredible technological capabilities, but has also opened new frontiers in our understanding of the solar system's history. The samples it has returned will continue to provide valuable scientific insights for generations to come, making this mission a pivotal moment in the history of space exploration. The Hayabusa2 mission, orchestrated by the Japan Aerospace Exploration Agency, represents a remarkable achievement in asteroid exploration that pushed the boundaries of what we thought possible in space missions. Following the success of its predecessor, Hayabusa, this ambitious mission set out to explore asteroid Ryugu, bringing revolutionary techniques and unprecedented experiments to asteroid exploration. One of the mission's most extraordinary accomplishments was the creation of an artificial crater on Ryugu's surface, a feat never before attempted on an asteroid. On April 5, 2019, Hayabusa2 deployed the small carry-on impactor, essentially a space cannon that fired a copper projectile at the asteroid's surface at approximately 2 kilometers per second. This controlled impact created a crater roughly 10 meters in diameter, exposing the asteroid's subsurface material that had remained untouched for billions of years. This bold experiment not only demonstrated humanity's capability to alter asteroid surfaces, but also provided invaluable data about Ryugu's composition and structure. As Hayabusa2's cameras and instruments studied Ryugu up close, scientists made a fascinating discovery about its nature. Rather than being a solid, monolithic rock, as some might imagine, Ryugu revealed itself to be what scientists call a rubble pile asteroid. This means the asteroid is essentially a collection of rocks and debris held together by its own weak gravity, like a cosmic bag of gravel floating through space. This structure suggests that Ryugu likely formed from the remnants of a larger body that was shattered by a collision in the ancient past. The discovery has profound implications for our understanding of asteroid formation and evolution in the solar system. The mission reached its climactic moment in December 2020 when its sample return capsule successfully landed in the Australian outback. This remarkable achievement marked the end of a 6-year journey through space, bringing back precious samples collected from both Ryugu's surface and subsurface materials exposed by the artificial crater. The samples, carefully sealed and protected during their journey through Earth's atmosphere, represented the first substantial collection of material from a carbon-rich asteroid of this type. The samples from Ryugu are particularly valuable because they contain some of the most primitive material ever returned to Earth. Unlike meteorites, which are contaminated and altered by their passage through Earth's atmosphere and exposure to our environment, these samples are pristine, preserving their original cosmic characteristics. Initial analyses have revealed that they contain organic molecules and water-bearing minerals, providing new insights into the early solar system and potentially the origins of life on Earth. JAXA's innovative approach to the mission included multiple touchdown maneuvers, the deployment of small rovers that hopped across Ryugu's surface, and the creation of the artificial crater, all of which have set new standards for asteroid exploration. The success of Hayabusa2 not only demonstrates Japan's technological prowess in space exploration, but also contributes significantly to our understanding of these ancient celestial bodies. The legacy of Hayabusa2 continues to influence asteroid exploration strategies and technologies, paving the way for future missions to small bodies in our solar system. As scientists continue to analyze the returned samples, each new discovery helps piece together the puzzle of our cosmic origins, making this mission a pivotal moment in the history of space exploration. The mission stands as a testament to human ingenuity and international collaboration in space exploration, reminding us that the quest to understand our cosmic neighborhood knows no national boundaries. Each discovery from the Hayabusa2 mission brings us closer to understanding our place in the vast cosmic ocean and the processes that shaped our solar system billions of years ago. Recent asteroid missions have unveiled extraordinary findings that are reshaping our understanding of the solar system and Earth's history. These discoveries range from potential future impact scenarios to profound insights about our planet's early days, making them crucial pieces in the cosmic puzzle we've been trying to solve for generations. One of the most attention-grabbing discoveries concerns asteroid Bennu and its future relationship with Earth. Through precise orbital calculations and detailed observations from the OSIRIS-REx mission, Scientists have determined that Bennu has a 1 in 1,750 chance of impacting Earth in the late 22nd century. While these odds might seem alarming at first glance, they actually represent a relatively low risk. However, this calculation has proven invaluable for improving our understanding of asteroid orbital dynamics and the factors that influence their paths through space. The precise tracking of Bennu's movements has allowed scientists to better understand the Yarkovsky effect, a force caused by thermal emissions that can gradually alter an asteroid's trajectory. Perhaps one of the most groundbreaking revelations came from the analysis of samples returned by Japan's Hayabusa2 mission from asteroid Ryugu. As Dr. Hiroshi Yamamoto, chief scientist of the Hayabusa2 mission, explains, the analysis of Ryugu samples shows that asteroids may have brought water to primitive Earth. This finding provides compelling evidence for a theory that scientists have long contemplated, that Earth's oceans might have originated, at least in part, from ancient asteroid impacts. The samples contained water-bearing minerals and organic compounds, suggesting that similar asteroids could have delivered these essential ingredients for life during Earth's early history. This discovery fundamentally changes our understanding of how our planet acquired its water and potentially how life itself might have begun. These ancient space rocks serve as genuine time capsules, preserving material from the solar system's birth approximately 4.6 billion years ago. Unlike rocks on Earth, which have been continuously transformed by geological processes, weather and erosion, asteroids have remained largely unchanged since their formation. They contain pristine material that hasn't been altered by planetary processes, providing us with an unparalleled window into the solar system's past. The samples returned from both Ryugu and Bennu contain organic compounds, amino acids, and minerals that date back to the very beginning of our solar system's history. The chemical composition of these asteroids has revealed surprising complexities. Scientists have found evidence of chemical reactions that occurred in the presence of liquid water, suggesting that even these seemingly barren rocks once hosted dynamic chemical environments. These findings are particularly significant because they indicate that the building blocks of life might have been present in the solar system's earliest days, even before planets fully formed. Analysis of the asteroid samples has also provided new insights into the distribution of elements throughout the solar system. The presence of certain isotopes and rare elements in specific proportions helps scientists track how materials moved and mixed during the solar system's formation. This information is crucial for understanding how planets accumulated their current compositions and why they ended up in their present locations. Moreover, these discoveries have implications for future space exploration and potentially even resource utilization. The confirmation of water-bearing minerals and valuable elements in asteroids supports the possibility of future space mining operations and the establishment of deep space refueling stations using resources extracted from asteroids. The revolutionary nature of these discoveries extends beyond their immediate scientific value. They represent a fundamental shift in our understanding of cosmic processes and Earth's place in the solar system. Each new finding from these asteroid samples adds another piece to the complex puzzle of our cosmic heritage, helping us better understand not just where we came from, but potentially where we're heading as a spacefaring civilization. These discoveries continue to yield new insights as scientists apply increasingly sophisticated analytical techniques to the returned samples. The knowledge gained from studying these cosmic time capsules will influence scientific thinking and space exploration strategies for decades to come, making them truly revolutionary in every sense of the word. The successful completion of recent asteroid missions has opened up exciting new possibilities for the future of space exploration, with upcoming projects promising even more ambitious goals. From planetary defense to resource utilization, the next generation of asteroid missions is set to push the boundaries of what humanity can achieve in space. The DART mission marked a historic milestone in 2022 when it successfully altered the orbit of asteroid Dimorphos, demonstrating humanity's first-ever planetary defense capability. This groundbreaking achievement proved that we can intentionally change an asteroid's path through space, a capability that could one day save Earth from a potentially catastrophic impact. The mission's success has spawned new initiatives and follow-up missions, including ESA's Hera mission, scheduled to launch in 2024, which will study the impact crater and precise orbital changes caused by DART. This new era of planetary defense has transformed asteroid missions from purely scientific endeavors into practical applications for protecting our planet. Looking ahead, several space agencies and private companies are developing missions to explore metallic asteroids, a new frontier in asteroid exploration. NASA's Psyche mission, targeting the metal-rich asteroid 16 Psyche, represents one of the most ambitious of these projects. This asteroid, believed to be the exposed core of an ancient protoplanet, could provide unprecedented insights into planetary formation and the early solar system. The mission could also offer valuable information about the composition and structure of Earth's own metallic core, which is impossible to study directly. The prospect of asteroid mining has moved from science fiction to a serious consideration for the future of space exploration and resource utilization. Several companies and organizations are developing technologies for extracting valuable resources from asteroids, including precious metals, rare earth elements, and water ice. Water extracted from asteroids could be split into hydrogen and oxygen for rocket fuel, potentially creating refueling stations for deep space missions. Companies like Asteroid Mining Corporation and Deep Space Industries are developing innovative technologies for prospecting and extracting resources from near-Earth asteroids. The potential economic impact of asteroid mining is staggering. A single medium-sized metallic asteroid could contain more platinum group metals than have ever been mined in human history. According to recent studies, the asteroid belt between Mars and Jupiter contains resources worth an estimated quintillions of dollars. While the technical challenges remain significant, advances in robotics, artificial intelligence, and propulsion systems are bringing this possibility closer to reality. Future missions are also likely to incorporate new technologies that will revolutionize how we study and interact with asteroids. These include autonomous navigation systems, advanced sampling mechanisms, and in situ resource utilization (SRU) technology. Small, efficient spacecraft, known as CubeSats, are being developed for asteroid exploration, potentially allowing for multiple simultaneous missions at a fraction of the cost of traditional spacecraft. International collaboration is becoming increasingly important in future asteroid missions. The successful partnership between NASA and JAXA in the Hayabusa2 sample analysis has paved the way for more collaborative efforts. The European Space Agency's proposed Hera mission, working in conjunction with NASA's DART mission, exemplifies this trend toward international cooperation in planetary defense. Commercial space companies are also playing an increasingly important role in asteroid exploration. Companies like SpaceX and Blue Origin are developing heavy-lift rockets that could make asteroid missions more frequent and cost-effective. Private-public partnerships are likely to become more common, combining government expertise with private sector innovation and efficiency. The development of new propulsion technologies, including solar electric propulsion and advanced chemical propulsion systems, will enable faster travel to asteroids and more efficient operations once there. These advances could make it possible to visit multiple asteroids in a single mission or to maintain long-term operations at an asteroid. Looking further into the future, some scientists envision establishing permanent bases on larger asteroids, using them as stepping stones for deeper space exploration. These bases could serve as scientific research stations, mining operations, and fuel depots for missions to Mars and beyond. As we continue to develop these technologies and capabilities, the future of asteroid missions looks increasingly promising. From protecting Earth from potential impacts to utilizing space resources for the benefit of humanity, asteroid exploration will play a crucial role in humanity's future in space. The next decade promises to be an exciting time for asteroid missions, with each new project building upon the successes of the past while pushing forward into unexplored territory. As we reflect on the remarkable achievements in asteroid exploration, we stand at a pivotal moment in human history. Each grain of dust retrieved from these distant celestial bodies serves as a unique window into our cosmic past. These microscopic particles, billions of years old, contain the fundamental building blocks of our solar system and potentially hold the keys to understanding how life emerged on Earth. We are truly living in the golden age of asteroid exploration. The successful missions of OSIRIS-REx, Hayabusa2, and others have demonstrated humanity's growing capability to reach, study, and even manipulate these ancient space rocks. The technological advances that enabled these missions have transformed what was once considered impossible into achievable reality. Our ability to precisely navigate spacecraft to distant asteroids, collect samples, and return them safely to Earth represents one of humanity's greatest technological accomplishments. The future holds even more exciting possibilities. As we continue to analyze the samples returned from Bennu and Ryugu, new questions arise that will drive future missions. What other secrets lie hidden in these cosmic time capsules? Could they reveal more about the origin of Earth's water? Might they contain organic compounds that contributed to the emergence of life? The possibilities are as vast as space itself. The significance of these missions extends beyond pure scientific discovery. They demonstrate the incredible achievements possible when international collaboration meets human ingenuity. From NASA's precision engineering to JAXA's innovative sampling techniques, these missions showcase the best of human capability and determination. They remind us that space exploration isn't just about reaching distant objects. It's about understanding our own place in the cosmos. As we look ahead, asteroid exploration will undoubtedly play a crucial role in humanity's space journey. Whether it's developing planetary defense strategies, advancing mining capabilities, or uncovering more secrets about our solar system's history, these missions are laying the groundwork for humanity's future in space. Each discovery builds upon the last, creating an ever-growing understanding of our cosmic neighborhood. If you found yourself as captivated as I am by these incredible space missions, I invite you to join our community of space enthusiasts. Subscribe to Exploring the Universe channel and give this video a thumbs up. Together, we'll continue to explore the mysteries of the cosmos, one asteroid at a time. The journey of discovery is far from over. In fact, we're just getting started. Let's remain curious, keep asking questions, and never stop exploring the wonders that lie in the vast expanse above us.